Hello everyone, welcome back to Under the Apple Tree, and today we're going to be going over L'Hopital's rule. This is a combination of limits and derivatives, so hopefully if you're here you already have a pretty good understanding of both of those ideas. Let's just go ahead and jump right in. So the first question is going to be find the limit with and without L'Hopital's rule and compare your answers. So there's a way to do this just algebraically, and then there's a way to do this with the calculus. And so we're going to do both ways and compare the answers. So let's just take the limit first. Because after all, L'Hopital's rule is just taking limits. So let's take the limit. So we'll get 2 squared minus 4, that's 0 on top, over 2 squared plus 4 times 2. So that right there, 4 plus 8, 12, minus 12, 0. So we have 0 over 0. And so what that means is that there's a hole at x equals 2. X equals 2. So now we have two options. We can do L'Hopital's rule, or we can attack this algebraically. It doesn't matter. L'Hopital's rule is definitely more consistent though. And let's do L'Hopital's rule first. So we're going to take the derivative of the top. Derivative of x squared is just 2x. Minus 4, derivative of that is 0. Derivative of the bottom, 2x plus 4. And now we take the limit to 2 again. We're going to get 2 times 2 on the top, 4. Plus 2 times 2 on the bottom, 4 plus 4, 8. So our answer is 1/2. Okay. Now we have the opportunity to check our answer by taking the limit without L'Hopital's rule. And if you don't know how to do this, it's very simple actually. You just factor out your original limit. So we're going to do that. So x squared minus 4 can be broken up. Let me just draw a little line here so we know it's a different section. We're going to factor this out. X minus 2 and x plus 2. And then now we need to factor the bottom, and that's going to factor out to x plus 6 and x minus 2. Okay, now this is still a limit problem. We're still taking the limit as x approaches 2. And if you notice, if you plug in 2 at this point, you will find that these two will equal 0, and so you'll get 0 over 0 again. But we see that since there's an x minus 2 on the top and bottom, that they're both going to cancel each other out. And so now there will be a limit. But note, if these don't cancel out, you cannot use this method. They have to cancel out. And so now we just take the limit. And that's going to get 4 on top, 2 plus 2 on top is 4, and then 2 plus 6 on the bottom is 8. 4/8, and that's going to equal 1/2. Let's look, we got the same answer, 1/2 and 1/2. So that's a good way to check your answer using L'Hopital's rule if you have polynomials on the top and bottom that you can factor. And then just make sure that the two terms that will make 0, they have to cancel out for this to work. But all in all, not too difficult of a process. Let's get on the next example. Find the limit as x approaches 0. Well, let's go ahead and take the limit. Plug in 0. 0 squared, 0 minus 3 times 0, that's just 0. Plus 3 sine x, sine of 0 is 0. 0 on the top. And then at the bottom, 1 minus cosine of 0. Cosine of 0 is 1. So 1 minus 1, that's going to equal 0 over 0. So now we have to use L'Hopital's rule. We can't use our factoring method here because there's not really a polynomial. We have sines and cosines, so we know we can't really do any factoring techniques here. Let's go ahead and take the derivative. Let's rewrite our limit statement really fast. Limit as x approaches 0. Okay, derivative of x squared, 2x. Minus 3x is just going to be 3. Plus 3 sine is going to be plus 3 cosine. Derivative of sine is cosine. 3 just stays in front. And then now we take the derivative of the bottom. Derivative of 1 is 0. Derivative of cosine is negative sine, but our cosine is already negative, so that's going to come out to a positive sign. You got to watch your signs here. Sine of x. Okay. Now let's do it again. Now we've done L'Hopital's once, now we'll take the limit. 2 times 0 is just 0, minus 3, that's just going to stay the same, plus 3 cosine x. Cosine of 0 is 1, 3 times 1 is 3, so minus 3 plus 3, so we have 0 on the top, and then sine of 0 is 0. So we got another 0 over 0. What does this mean? Well, the beauty of L'Hopital's rule is you can do it as many times as you need. Hopefully we don't have to do it more than like twice, because then it gets really annoying. But this isn't too bad, what we're at this point. So let's just go ahead and take the limit again. Limit as x approaches 0. Okay, derivative of 2x is just 2, plus 3 cosine, that's just going to be, well, derivative of cosine is negative sine, so I'm going to have to make a negative 3 sine x all over. Derivative of sine is just cosine, positive, make sure. Okay, so now we can take our limit. So the 2 stays the same, minus 3 sine 0. Sine of 0 is 0. This should be cemented in your brain by the end of this problem. We've done so many limits to 0 of sine. And then cosine of 0 is just 1. So we finally have an answer here. We're going to get 2 over 1, or just 2. So the limit as x approaches 0 is 2. There is a hole at x equals 0, though. Hole at x equals 0. So there's a hole there, but for limits it doesn't matter if it's defined there. It just has to approach it. So it approaches it, but it's not defined at that point. Let's get on to the last problem here. Find the limit. Okay, so this looks very similar to what we just did. Let's go ahead and get at it. 1 minus 3 cosine of 0. Let's just plug in our limit here. We're going to have 1 minus 3 times 1. Cosine of 0 is 1, so just negative 3 right there, all over sine squared of 0. Well, sine of 0 is just 0. It doesn't matter if it's squared. 0. And so we get negative 2 over 0. And what does this mean? So this isn't a 0 over 0. L'Hopital's rule can only be used if it's 0 over 0. So the fact that we're getting a negative 2 over 0 means that we cannot use L'Hopital's rule. And what's the significance of this negative 2 over 0? What does it mean? Well, this means that we have a vertical asymptote. I'm just going to write VA. A vertical asymptote at x equals 0. This is really poor handwriting. Let me redo this. Yeah, that means it's a vertical asymptote. So if you get 0 over 0, that means it's a hole. But if you get a number over 0, then you know it's a vertical asymptote. Vertical asymptote at x equals 0. Okay, so how do we solve these problems? Well, if you remember, you just treat this as a limit to infinity problem. Forget about L'Hopital's rule. This is just a normal limits problem. So how do we know if the limit exists or not? Well, we have to make sure the right hand and left hand limits are equal to one another. So we're going to find the limit of x to 0 from the left, and also the limit x to the right. Now if you don't remember how to do limits to infinity, check out my other video. I'll put it in the description. But these two limits have to be the same. And so when you're doing limits to vertical asymptotes, it'll either be positive or negative infinity. And so we're just going to go ahead, and since it's positive and negative infinity, it doesn't really matter what the signs are. All what matters is if the signs are the same or not. So what's the sign as x approaches 0 from the left? So we're thinking negative numbers. What will happen to this top function here? What will happen to 1 minus 3 cosine x? What's going to happen to that? How does it behave as x negatively approaches it? Well, let's look at a graph just to make this easier. The one in blue is a cosine graph here. Ignore the red one for now. This blue one's cosine. And if you look at it, it doesn't matter if x is positive or negative. If you look at the -1 here, it's right between the second and third horizontal line. And it's the same for the positive. It's what we call an even function. It reflects over the y-axis. So it doesn't matter if the input is negative, the output will always be the same. Okay, so what this means is that whatever our sign is for the negative limit, it's going to be the same as the positive limit. For the numerator, of course, we haven't talked about sine squared x yet, but for the numerator, our signs are going to be the same for both the right hand and the left hand limit, which is really nice to know. So let's just take a look at this and think about it conceptually. So as x gets bigger, it is going to overpower that 1. 1 minus 3 cosine. That 1 is going to get overpowered by the 3 cosine very quickly. So we know it's going to be a negative sign on top. Negative sign on top. Same over here. Remember, since this is an even function, whatever happens on the left will happen on the right. Okay. Well, sine squared x is not an even function. We're going to have to treat this one a little bit differently, but if you guys notice, the function is squared. That means it doesn't matter what you input. The answer will always be positive. Anything squared will come out positive. So we know it's going to be positive. It doesn't matter if our inputs are negative. Put in our negative inputs, positive answer. Put in positive inputs, positive output. It doesn't matter. We get negative over positive. And so what this means here, negative divided by positive is just a negative, and that means we approach negative infinity from the left. Same story here. Approach negative infinity from the right, and that means the overall limit is negative infinity. And if this doesn't make sense, we can take a look at it graphically just to cement your understanding. And so now we're just going to focus on the red graph here. This is the graph of 1 minus 3 cosine over sine squared. And look here, so we know there's a vertical asymptote at 0. It's horizontal, or this vertical line 0. So we know it should never touch it, but it's approaching it. And they're both going downwards. They're both approaching negative infinity, so we know that our limit approximation was correct. That's going to do it for this video, guys. I hope you learned something. Good luck on all your exams and homework. See you next time.